So, good evening, everyone. Welcome to week 12 of the live session for the course Industrial Wastewater Treatment. I am Niketa. I am a PhD student from IIT Madras, and I'll be your live session TA for this course. So, what we will do over this session is I'll give some brief explanation about some selected topics that you must have seen through this week's lectures, and then we will have a question and answer session if you have any doubts. So, before we start, do you have any questions from the previous week's lectures or from what you have watched in this week's lectures? Okay, so if there are no questions, then I'll proceed. So this week is about acid mine drainage wastewater or the mining wastewater in general. So mining industry, mainly we'll focus on the coal mining industry. So India has a very big deposit of coals, has about 293.5 billion tons. But most of this coal has low sulfur content. Which is good because we will be generating a lot of sulfur dioxide if it had a lot of sulfur content. But the coal that we have in India is high in ash content. So if ash content is high, then we will be generating a lot of fly ash. Now, fly ash is the ash which is generated, but which is having a very small size, so it can come out along with the flue gases. Now, flue gases are the hot gases that are generated during the coal burning process. So when coal is burned in thermal power plants or in some other industries, then along with heat, they will also generate some gases. And along with the gases, fly ash will be produced. So fly ash is actually a type of ash. There are different types of ashes, bottom ash and fly ash. So bottom ash will stick to the bottom of the furnace, but fly ash generally comes out of the stack along with the gases. So it needs to be trapped at the exit of the stack. So fly ash is an air pollutant because it has a smaller size, so it can easily enter our airways and it can get lodged in the lungs. And sometimes fly ash can also contain other contaminants like heavy metals or other organics which are harmful. So we have to ensure that the fly ash does not spread into the air or it doesn't reach any waterway. So yeah. So there are different types of coals which are mainly found in India. We have just two major types. The first one being the Gondwana coal field. So this is mainly around central India in places like Madhya Pradesh, Chhattisgarh, and Odisha. And the next type that we have is tertiary coal fields. So this is mostly found in the northeast India, in places like Assam, etc. So this constitutes only about 0.5%. So this is very minimal. Even though the sulfur content is high and the ash content is low in tertiary coal fields, their availability is actually very less. So they constitute only 0.5% of the total coal deposits that we have. The rest is dominated by the Gondwana coal fields, which has a low sulfur content and high ash content. And The Gondwana coal produces alkaline mine water. So produces alkaline mine water. Meaning the mine wastewater that is produced in Gondwana coal while mining Gondwana coal is more alkaline and it is less polluted. Whereas the waste that is generated while mining tertiary coal fields are acidic, and it also has a lot of dissolved metals. Now, why it should have dissolved metals? It's because acidic, generally, if it is a highly concentrated acid, then and if it is especially percolating through rocks, then it can actually dissolve the minerals in the rocks, which contain a lot of metals, and then the acidic wastewater will be high in dissolved metals. Okay, so now coming to the definition of mine water or the mine wastewater. So this is water which has a high amount of inorganic and suspended impurities. And also has a lot of dissolved metals. And it can be classified into alkaline and acidic mine water. So first coming to the alkaline mine water. Alkaline mine water can be subclassified into three categories. So they are A1, A2 and A3 based on their hardness and TDS. So the lowest hardness and TDS is in A1. Whereas in A3 it is the highest. Okay. Then coming to acidic mine water or acidic mine drainage. So here, in the presence of water and oxygen, sulfide metals get oxidized, and this generates a lot of H plus ions. So the H plus ions lead to a lower pH, so the pH becomes 2 to 5. And in this pH, heavy metals like aluminum, iron, manganese, and copper are leached because they are highly acidic, so they leach out of the minerals. And this kind of wastewater, because it contains iron, so it can also form ferric hydroxide if there is some reaction with alkalinity or alkaline content, or if like iron comes in contact with water, and in such cases ferric hydroxide can form. So ferric hydroxide forms a yellow substance which is also called yellow boil. So this kind of acidic mine drainage water will have a lot of ferric hydroxide which leads to its yellowish color, and this yellowish color can deposit on surfaces. And it also becomes toxic to plants and animals, and it can contaminate both groundwater and river water. So when it is introduced into the soil, it reduces the fertility of the soil also. So The strategy to manage coal wastewater is to rigorously treat the acid mine waste, and to reuse the alkaline mine waste. So this is a strategy for treatment. So coming to the actual treatment process, the first step is neutralization. This is especially done for acid mine waste. Now, neutralization is done by adding any alkaline substance like lime or limestone. Now, the next one is a passive process, meaning it's a slow process. It's not as fast as neutralization, where chemicals are added to reduce the acidity. So, the passive treatment includes wetlands. So, can someone tell me what are wetlands? What are wetlands? You must have heard of it as a treatment process, right? So, can someone explain me? So, wetlands or even constructed wetlands are treatment systems where plants are used. So here we let the wastewater pass through a patch or a field of plants. So then the plants they uptake the water, and then they also ensure that the treatment process happens by uptaking most of the pollutants. So they either store them inside the roots or they you know use them for their growth. So yeah, it is a type of phytoremediation. So yeah, that is a wetland. The third type is biological treatment using microbes. So this you must have already seen. There are many types like fixed film, attached growth, suspended growth, or even hybrid. And during this, it is also important to do metal recovery. So if there are any dissolved metals, then they should be recovered. And then that is followed by dewatering sludge. So yeah. Now, active methods are preferred over passive methods. The reason being that active methods they allow the recovery of precious metals. And they also generate lesser pollution compared to the passive methods. Now, in case there are pollutants like cyanide, so cyanide can be removed by alkaline chlorination. Or oxidation using hydrogen peroxide. Okay, this was the acid treatment. Now coming to the treatment of alkaline mine water. So the first step is aeration. So aeration, if sufficient air is provided, then iron and manganese will get oxidized and they will form precipitates, and then they can be separated. So aeration is especially used for precipitation of dissolved manganese and iron. And we can also do chemical treatment. Using alum and lime, especially for coagulation and flocculation. You can also use a pressure filter and softeners. Using ion exchange or lime soda. And finally, disinfection. Using chlorination. So, as in any case, here also the choice of treatment depends on the quality and the characteristics of the wastewater and what financial resources are available. So, depending on that, we have to decide the type of treatment. So, how are these mine wastewaters created? First, while mining, the rock piles are created, right? So, these rock piles contain a lot of heavy metals. And when rainfall happens, the rain infiltrates the rock pile. So when this happens, the metals get dissolved into water and they percolate down. So percolation down means, like, imagine this is your uh, ground level and mining happens somewhere here. So imagine this is an aquifer. So an aquifer is an underground uh, rock which contains water, which is porous and holds a lot of water. So usually this is where we get the groundwater from. Usually bore wells are drilled through the rock so that the water inside can be collected. So during mining, so the aquifer could get perforated, or it can, you know, hole can be drilled through it. So if you have a lot of rock piles or waste rocks that are lying around which have heavy metals in them, so they can get dissolved with the rainwater, and then once the rainwater enters the aquifer, the heavy metals also enter along with that. So what happens essentially is a source of groundwater gets contaminated with heavy metals. Now, when this water is taken out using a bore well, like not here exactly, but these aquifers can be interconnected in many instances. So this can be a big aquifer, and then there could be some minor channels which could be flowing between one aquifer to another one, so they could be somewhat interconnected. So when this happens, the metals travel from the source to all the way throughout, and wherever there is a bore well which extracts the groundwater, so the heavy metals can come up through it, and then they can reach the uh, people who are drinking it. So that is a possibility. So if we have to avoid this, then we have to ensure that the heavy metals are recovered and they are removed before discharging, or like before the rainwater gets to infiltrate through the aquifers. So the conventional processes that are used for treatment is neutralization, and precipitation. Yeah, you have a question?
Yes, ma'am. Ma'am, can you explain aerobic wetland and anaerobic wetland?
Aerobic and anaerobic wetlands. Okay, so today is the last class, so maybe I'll just try to include it in the notes and I'll upload it. Is that okay? I don't see a response.
Uh, yes, ma'am.
Okay. So for neutralization and precipitation, especially for precipitation, lime, alum, or iron sulfate is added as coagulants, and this makes the metal precipitate as metal carbonates, hydroxides, and so on. So they can be easily separated. So the second way of treatment is through high rate algal ponds. So high rate algal ponds generate a lot of alkaline waste. So this alkaline water can be added to the acidic water to neutralize it. And we can also do biological treatment using sulfate reducing bacteria. To convert the sulfate to sulfide, and if there is excess sulfide, that can be removed using sulfide oxidizing bacteria. And we can also do alkaline injection technique. So this is injecting some alkaline solution directly into the acidic mine discharge. So this will neutralize the acidic mine waste water. Then phytoremediation. So in phytoremediation, there is plant uptake where heavy metals are directly absorbed by the plants, and they also get immobilized by the plants, especially by the bacteria. So certain bacteria will form metal plaques or metal plaques. So these metal plaques are formed at the root of the plant. So the metal gets immobilized there, so it cannot move. Alright. So let's now come to industrial symbiosis. So you must have come across this term called symbiosis, like algal bacterial symbiosis, especially in oxidation ponds. So it is industrial symbiosis is quite similar to it. So here the industries that are located in a close proximity to each other. Um, yeah, yeah,
Madam,
yeah.
in shoot treatment,
Huh?
uh, alkaline injection technology
Yeah.
is used when
Sorry.
alkaline injection technology
Huh?
in tube treatment.
Your voice is
Mm,
breaking.
Okay, ma'am.
Can you type your question? Please type your question.
Typing.
Have you typed the question?
Wait, ma'am, I will try.
Yeah, in situ treatment, but what is your question? In situ treatment. In situ treatment is where, if a site is like contaminated. So, especially in case of groundwater or soil which is contaminated, uh, we directly add chemicals to remove the contaminant at the site. So, since it is being done on site, it is called in situ treatment. So, ex situ treatment would mean taking out the soil or the groundwater, transporting it to a treatment site, and then treating it. But in situ involves treatment on site. So, we can add even some kind of bacteria, some chemical agents, or something which can remove the pollutant from the site of contamination. Is that clear? Okay, so like you said, alkaline injection is a type of in situ treatment. Okay, so coming back to industrial symbiosis. So, symbiosis generally means a process where uh, multiple parties are involved and they all mutually benefit from each other. So, like in the case of algae and bacteria, so similar to that, we have industries that are located in close proximity to each other. So, the pollutant that comes from one industry, so so let's call it industry 1, becomes so the pollutant from industry 1 becomes a raw material or feed for the second industry. So this creates a circular loop where zero discharge is going to be there, because whatever waste is generated is going to be utilized by some other industry and vice versa. So overall, there is going to be less discharge from the industrial cluster. So this involves processes like capturing, understanding what waste is generated, what industries are located in the neighborhood, and what wastes are generated by each industry. So that comes under capturing. Second one is recovery. So recovery means extracting any valuable substance and diverting them as primary inputs. So that comes under recovery. The third one is reuse. So reuse means actively using the wastes into new products. So this creates a sustainable environment. So the main requisite for industrial symbiosis to function is to ensure that industries are located close to each other. So this is very important, because if the quantity of waste that is generated or the quantity of waste that is required to be used as a raw material is huge, then and if the distance between the two industries is also very high, then imagine how much fuel will be required for transporting the waste from industry 1 to industry 2. So we would need maybe a lot of energy, and energy, buying energy means spending money, so we will also have to look at the economics and the finances. So overall, this is going to be an expensive and energy intensive process if the industries are located far away. But if they are located in close proximity, then all of this can be avoided. And yeah, that is why it is a prerequisite for industrial symbiosis to exist in a place where the industries are located close to each other. And industrial symbiosis helps enforce circular economy. So before going into circular economy, let's look at the difference between linear economy versus circular economy. So can someone explain what is linear economy? What is linear economy? So linear economy is where you have some raw material which undergoes some processes, some industrial process, and then it is converted into a product. And there is also waste generation during the process. So the, it is very simple, right? Some raw material is available, it undergoes some processing to generate a product, and meanwhile the waste is generated. So that's it, that's the end of the line. So when compared to a circular economy, so in a circular economy, what happens is we have the raw material, okay, so that gets converted into product, or it can also have some waste. So this waste goes back and gets used as a raw material. So this creates a circularity where whatever goes in comes out and again goes back in. So this creates a cyclic process. So that is your circular economy. So unlike a linear economy, which just goes in one direction, that is the waste that is generated, is just there. But instead, in a circular economy, the waste is reused and it doesn't reach the end of the line. So it is always going to be used in the process. So compared to a linear economy, a circular economy produces lesser waste and also ensures less demand for raw materials. Now, for example, if we have cement plants, so cement industries or cement plants, they utilize wastes from many industries. So, just to give you context, so they can take wastes from the construction and demolition industry. Especially if there is concrete blocks which are wasted, and they can take wastes from the ceramic and sand industry. They can also take wastes from thermal power plants. So I told you in the beginning of the class about fly ash, right? So fly ash that is generated in thermal industries. Yeah, just coming to it. So fly ash generally has a lot of impurities. So in that case, the fly ash needs to be treated. It needs to be stripped of impurities. So in case if there is a high chance of impurity, then the fly ash cannot be used. So after sorting the impurities away from the fly ash, so that can be given back to the cement plant. So that's how the waste from thermal plants come to cement industries. And then from iron and steel industry. So these are the ways in which the cement plants utilizes wastes from other industries. So there are other examples also. But before that, let's look at the drivers of industrial symbiosis. So, prerequisites or some factors which drive the symbiosis, industrial symbiosis, are diversity of industries. What this means is that if the industries are diverse, um, in the sense that just how we saw in this example here, a cement plant is very different from a thermal power plant or an iron and steel industry. So, if there is some diversity like this, then it becomes possible that the waste from one industry goes to another industry as a raw material. But if all of them were connected industries, then that is going to be impossible. So, diversification is very, very important. If the same kind of industries exist over a location, then all of them would want the same kind of raw materials. So providing that will become very difficult. So the industry should be diverse enough that the raw materials for each of them are different, and possibly the waste from one industry becomes the raw material to another one. And the second requirement is favorable legislation and policy. So this is, government policies and the legislation should ensure that it encourages industries to, collaborate and set up, get set up in places where they are in close proximity with other industries to drive this symbiosis forward. The government can give some incentives, or it can give some exemptions. So all of this can come under policies and regulations. Economic and financial incentives. So these incentives can be given by the government, uh, like exemptions from paying certain kind of taxes, or giving them a piece of land which is close to the market or the transport hub, so on. So these incentives can be given, and apart from this, there are also financial incentives in terms of like if the raw material required is very expensive, then taking it as a waste can become a much cheaper option. So if it is already a waste, then it is going to be sold at a lower price. Yeah, that leads us to the next point, the price of raw materials. So, if the price of raw materials when bought fresh is going to be quite high, then it is possible that industries might look at wastes from other industries which are cheaper. The fifth one is scarcity of raw materials. Now, similar to being expensive, if the raw materials are also scarce, meaning they are not generally available in a huge quantity, then that would also lead to industries buying from each other. So, if all of these exist, then uh, or industrial symbiosis is going to be favorable. I mean, these conditions will favor industrial symbiosis. But there are also certain issues with this concept. The first one is that we need accurate material tracking and auditing. So this involves, accurately determining what kind of waste is generated, how much of it is generated, and how much of it is going to be required as a raw material in other industries. So all of this is required. So this is an extensive process, so which could take a lot of time and labor. It also involves determining which material is in the which stage of processing. So all of that. The next step is, the next issue is matching industrial output to feedstock requirements. So once we know how much waste is generated, we have to match it with the feedstock requirement. So if the feedstock requirement or the demand for raw material is quite high and the waste generated is very low, then there is no point in having a symbiosis because it is not going to be beneficial for the second industry. Third one is the stakeholder process. So this involves, in this process involves various stakeholders like the government and the industries. So getting an agreement between all three of them is going to be difficult, and we also need to have a combination of profit plus regulations and sustainability. So if this combination is not there, then um, it's going to be futile. So there needs to be profit from this process, and the regulations must favor the process. And overall, this process must improve sustainability or create a sustainable outcome. So if this is not there, then it is a futile exercise or something which doesn't have any uh, required outcome. It is going to be a waste. So another example similar to the cement industry is going to be the sugar industry. So in the sugar industry, bagasse and molasses are produced. The bagasse goes to the pulp and paper industry. The molasses goes to distilleries. Where the molasses are fermented. Now, from the distilleries, they also go to the fertilizer industries. So it can be directly molasses can be taken to the fertilizer industry. And whatever sodium hydroxide is generated from the pulp and paper industry, that can be recycled back. So that creates a circular process. Okay, this is just an example. Now coming to the socio-economic impacts of industrial symbiosis. So there are two kinds of impacts. The first one is positive and the second one is negative. So they are divided into the upper triangle and the lower triangle method. So the upper triangle focuses on processes, on effects that show some improvement. So the industrial symbiosis improves job prospects or job opportunities. Because recycling and then reusing it ensures sufficient jobs are available, because reusing doesn't always mean directly reusing, some processing might also be required. And This also improves the production level. Since the raw material is available at a close proximity, so there's no need for delay in transport. So they can be transported as and when required, and that improves the production levels. So the amount of the rate of production improves. And it also gives room for innovation, because when different industries are close by, so there is also always going to be people thinking how waste from one industry can be used for another industry. So that gives some room for innovation and resource utilization. On the other hand, the industrial symbiosis reduces certain things. So reduces resource requirements. So if fresh resources are not required, then they are going to be conserved. And it also reduces water consumption, especially if it is a zero discharge process. In that case, the wastewater gets recycled by the same industry which generates it, so there is less water consumption. There is also reduced hazardous waste generation. Lesser air emissions. Reduced transportation costs. So generally, if there is a cluster of industries, so they all generate wastewater, which is taken to a common effluent treatment plant. Also called CETP. So the functions of a CETP are first to homogenize the wastewater coming from various industries. Homogenization means ensuring that it becomes uniform. So wastewater coming from different industries could have different concentrations of various pollutants. So homogenization ensures that they are all mixed together, the concentration becomes uniform. And to also recover and recycle valuable materials. To also ensure compliance with environmental regulations. So, environmental regulations, like in India, we have CPCB, and outside India, we have the US EPA. So, treatment in a CETP has the following processes. First one is the preliminary treatment. Can someone recall what we saw in preliminary treatment? What are the processes that we saw under preliminary treatment? So I think there are some discharge standards. So discharge standards are only for treated effluent. So without treatment, there is like discharge standards won't be applicable. So anything is going to be high. So it's better to treat and then look at the standards. If they are complying with the standards, then it's okay to release into the environment. If they are not complying, then it's better to resend the water for treatment. So, what are the different preliminary treatment processes available? No, what I meant is discharge standards are applicable for treated wastewater. So, untreated wastewater cannot be discharged as such unless and until their BOD, COD, or other parameter levels are within the limits. If it is not, it has to be sent to a CETP. But as much as possible, it is preferred to reduce the occurrence of waste because we have to follow zero liquid discharge norms. So, yeah, companies should ensure that they do it. Okay, so preliminary treatment involves processes like screening, or using skimming tanks, etc. And then comes primary treatment. So, primary treatment involves using sedimentation tanks. Then, secondary treatment. So, secondary treatment involves biological processes. Tertiary treatment so this involves removing nutrients like nitrogen, phosphorus, and other recalcitrant organics. And then having polishing units. So polishing units include sand filters, activated carbon filters, and so on. And then sludge management. So sludge management involves processes like sludge thickening, digestion, and dewatering. So that's about treatment in a common effluent treatment plant. So with this, we've come to the end of this session. Are there any questions from your side?
Hello.
Yeah.
This is your last lecture, I think, and I have attended 6 or 7 lectures out of 12, and you have explained very well, ma'am.
Okay, thank you.
Thank you, ma'am. This is your recorded lectures, and it is useful at the time of exam also, ma'am.
Okay, I'm glad that you find it useful. Thank you for your compliment. Do you
Okay.
have any
Thanks, ma'am.
questions?
Yes, ma'am.
Do you have any questions?
No, ma'am. Actually, I have one questions regarding regarding uh, एक minute, 1 minute, ma'am. Mainly, uh, mainly uh, wetland in aerobic or anaerobic wetland. There is a plant above the. There is a plant. Then that plant can reduce the metal or metal level, or what is the purpose of that plant?
So the plant generally absorbs the metal. So it stores
Okay.
it inside its body. So maybe in the roots or in the leaves somewhere. So it doesn't let the metals get into the soil, or it doesn't allow the metal to flow through with water or contaminate the soil and so on. So it absorbs whatever contaminants it can.
Yes, ma'am. That plants reduce BOD, COD also, or only reduce the metals percentage.
Mostly it is employed for metals or any recalcitrant pollutants are there. So in those cases, we use wetlands, constructed wetlands.
This plant is a special plant to reduce metals.
Some cases, yeah, it is specialized.
Okay.
Not always,
Okay.
but in most cases, certain plants will have a higher, their digestive system, no, not their metabolism is, in such a way that they can utilize the heavy metals and other contaminants, and then they can continue to grow. So it depends on the plant. So in that cases, certain plants can absorb certain metals efficiently over other plants.
One more question, ma'am. In that passive method, or this type of uh, uh, first is water level, water layer, then organic matter level. Then it is aerobic or anaerobic, because if organic above the organic or solvents density is less than 1, and it is float on water, means it is converted to anaerobic.
No, I'm not understanding your question. Can you please repeat?
uh, in aerobic wetland, mainly water, effluent or water, and one layer of solvent or organic matter.
Okay.
The density of organic solvent is less than 1, then it is float on water, and water, the density of water is 1, so it is at bottom.
Okay.
Then it is anaerobic conditions or aerobic conditions.
So in this case, it becomes aerobic because if the pollutant is above the soil layer, then it is exposed to air. So in that case, it becomes aerobic.
Aerobic. Okay. Thank you, ma'am.
Right. So more on wetlands. So there are like aerobic as well as anaerobic wetlands, and wetlands are mainly used for aeration and for removing metals like iron, aluminum, manganese. So these are basically divided into aerobic and anaerobic. So aerobic wetlands have like a shallow depth, like up to 30 centimeters, and there are also variations based on the level of water inside them. So like if the water level is above the surface, like it is a free water surface, so then it can be used for removing wastewater which has a high organic or a BOD load, and for solids removal and so on. And the other one is the subsurface wetland. So here we use reed beds and all. So these are the two types. So mainly aerobic wetlands are very good for metal removal as well as BOD reduction, but they need to be in a suitable pH and also in a proper climate. So if that is there, then they are a very good option. They are highly sustainable for removal, and yeah, so that's about aerobic wetlands. So, do you have any other questions in this regard? So mainly, aerobic wetlands are used for promoting oxygen-rich conditions, and it is especially used when the cost of treatment or the budget has some limitations. So in that case, it can promote oxygen-rich conditions for the treatment. And most commonly, some reeds are used. So the plants that are commonly used include some kind of reeds. So yeah. And anaerobic wetlands, they generally don't allow oxygen exposure. So they mainly, we go for subsurface flow, that is flow below the surface of the soil. So that creates an anoxic system where anoxic bacteria and anaerobic bacteria break down the waste. So usually, if these two types are in series with each other, then that creates a very good condition for treatment. And yeah, like anaerobic wetlands are used for treating acid mine drainage waste. So that is more ideal. So if there are no further questions, then I'll end this session. So thank you all for joining, and these. I hope these 12 weeks were really helpful for you to learn more about this course and to clear your doubts and to gain some knowledge. And I wish you all the very best for your upcoming exams. And yeah, if you have any questions, you can always post it on the forum, so that I'll check it. Alright, so if there are no further questions, I'll just end this session. Thank you very much, all of you.